Let's try to find some solutions of the two-body problem. One of the easiest ways is to assume some special symmetries for the solution. Let's suppose that gamma 1 of t, which is the motion of the first body with mass m, is given by r1 times cosine of omega t, sine of omega t. We are assuming that gamma 1 moves on a circle. And we're also going to assume that the second body with mass m, this is gamma 1 of t, describes the motion for this one. And the second one is, this is the origin, is negative r2 cosine of omega t, sine of omega t. Right? This is the motion of the body m, gamma 2. Then when we compute the second derivative to use the Newton's second law, we get mass 1, mass m, times the acceleration, which is just negative r1 omega squared cosine of omega t, sine of omega t, equal to, in this particular case, the distance between the two bodies is just gamma 2 minus gamma 1 is always the same, is r1 plus r2, then is equal to, we are doing this, then it will be this vector, right, which is gamma 2 minus gamma 1 over the norm of gamma 2 minus gamma 1 cube times m times the gravitational constant. Right? And then when I do this gamma 2 minus gamma 1, I get a negative r1 plus r2 times m times the gravitational constant times cosine of omega t, sine of omega t over this is just r1 plus r2 cubed. Right? We can cancel an m here in this equation. And likewise, when we do the second derivative, mass times the second derivative here, mass times the second derivative, the second derivative will be r2 times cosine of omega t, sine of omega t, and then this is equal to the product of the masses times r1 minus r2 over the norm of this cube, and then we end up with r1 plus r2 times the product of the masses times g over r1 plus r2 cube times cosine of omega t, sine of omega t. And then we will get that we have a solution as long as we solve this system. r1 omega squared equal to m times g over r1 plus r2 squared, and r2 omega squared equal to m, what is that, this capital M cancel, times g over r1 plus r2 squared. That is that if we add these two equations, we will get that r1 plus r2 times omega squared is equal to mass times m times g over r1 plus r2 squared. That means that we have that r1 plus r2 must be equal to m plus m times g over omega squared, everything raised to the power of 1/3. And And when I replace this information here, I can find the R1, and when I replace this information here, I can get the R2. We get that R1 omega squared is equal to m times g over this quantity square over and likewise R2 times omega squared is, and then for any given omega we can get the R1 and R2. When we replace this information into these formulas, we get that and R2 is equal to that means that we have here a center. The center of the sun will move in a circle of this radius, and the earth will move in a circle of this radius. Notice that this is the circle. When the earth is here, the sun will be, the center of the sun will be here. This information is very accurate with the real information. The real orbit of the earth is an ellipse, but that ellipse is almost like a circle. The eccentricity is very small, and this radius will be a good approximation to that circle.